All right, welcome back. So if you've ever built anything for the cloud, you know the feeling. Getting all your applications to actually talk to each other can feel like wrestling with a giant, invisible puzzle. Well, today, we're going to demystify one of the biggest, most important pieces of that puzzle, Kubernetes networking. Let's just dive right in.
It all boils down to this one big question, right? You've got all these different microservices, all these containers and components humming along, but how in the world does a request from a user, out there on the internet, find its way to the exact right piece of code, and then how does that code talk back?
It can really look like a crazy maze of virtual wires and IP addresses, but I promise you, by the end of this, you'll see exactly how all these moving parts click together. We're going to make it make sense.
Okay, so our journey has to start at the absolute ground floor, the most fundamental building block of any Kubernetes app. And that means we're talking about pods. A pod is basically the home for your application's containers. It is the place where your code actually lives and does its thing. And here's the key. Everything inside that one pod shares the same network space. It's kind of like they're all roommates in the same tiny apartment using the same internet connection.
And to make this crystal clear, let's use an analogy we can all get behind. Picture a massive food court at the mall. Each individual food stall, the taco stand, the pizza place, the noodle bar, each one of those is a pod. It's its own self-contained little unit that does one thing really well. And boom, right away, we hit our first big problem. See, pods are designed to be ephemeral. That's a fancy word that just means they can be created and destroyed at any time. So if that taco stall gets a huge line, Kubernetes might spin up a brand new one to help out. And if it's slow, it might just shut one down to save money. So what happens when you try to send an order to a stall that just vanished?
You get this, that dreaded error message. Because every single pod has its own temporary IP address. If that pod gets deleted, its address goes with it. Poof, gone. You just can't build a reliable system by talking to something that's constantly changing its phone number. This is a massive issue.
So, how does Kubernetes get around this? Well, with a truly brilliant idea, an abstraction called a service. This is the elegant solution to our unreliable, disappearing pod problem.
Okay, so a service acts like a stable, permanent frontman for a whole group of pods. It gets a single IP address that never ever changes, even while the pods behind it are popping in and out of existence. It's your one reliable point of contact.
Let's jump back to our food court. The service is like the main ordering counter for tacos. You don't walk up to one of the 10 identical taco stalls yourself. No way. You just go to the big sign that says taco counter, and that counter intelligently routes your order to a stall that's actually open and ready to cook. It handles all that chaos for you.
So let's put it side by side. Pods are the workers. They're temporary. They come and go, and their addresses are totally unreliable. Services, on the other hand, are the managers. They provide that stable, unchanging address and act as a reliable director for all your traffic. You talk to the service figures out which pod to talk to. Simple as that.
Now, you might be thinking, okay, this is great for communication inside my cluster, inside the food court. But what about your customers who are outside the mall? How does all that traffic from the public internet find its way to our taco counter in the first place?
For that, we need the final, crucial piece of our networking puzzle, the ingress. Think of this as the main entrance, the front door, and maybe even the security guard for the entire food court.
So let's follow a single request all the way through. A user's request from their browser first hits the ingress. The ingress is a smart gateway. It looks at the request, maybe it's for tacos.com, and knows, aha, that goes to the taco service. Then it routes it to our director, the taco counter. Finally, the service forwards that request to an actual, healthy taco-making pod. From the gateway, to the director, to the final destination.
Okay, so we've got the theory down pat. It sounds pretty neat. But let's get real for a minute, because as any senior architect or developer will tell you, this is where things can get tricky. When you're running this stuff at scale, you hit some very real, very painful roadblocks. You can literally run out of IP addresses for your pods. Trying to debug a problem across all these layers can be an absolute nightmare. And the underlying network software itself can cause some massive headaches if you're not careful.
And I'm not being dramatic here. IP address exhaustion is a critical, show-stopping failure. Just imagine, it's Black Friday, your app needs to scale up to handle a massive traffic spike, but it can't create new pods because there are literally no IP addresses left to give them. Your app just stops scaling, and your users, they get errors. I just love this quote because it is so painfully true. When a request fails, where did it go wrong? Was it the ingress, the service, some weird firewall rule, a misconfigured pod? You have to become a digital archaeologist, digging through layers and layers of abstraction to find the root cause. It's why one of the first things you learn to do is just trace the path, checking logs at every single hop.
And, just to make things a little more interesting, the way all this stuff works under the hood can be really different depending on which cloud provider you're using. So the concepts we've talked about, pods, services, ingress, they're universal. That's the beauty of Kubernetes. But the actual software that's down in the weeds, creating the virtual networks and handing out IP addresses, that's called the CNI, the Container Network Interface. And yeah, each cloud provider has their own special flavor. And these details matter a lot. On AWS, for example, their CNI plugin pulls IP addresses directly from your main cloud network. Now that's simple, but the catch is you can burn through addresses for your entire network way faster. Azure, on the other hand, tries to get ahead of this by pre-allocating big chunks of IPs on each server, but that means you need to do a lot more planning up front. The key takeaway is that the foundation your cluster is built on is different everywhere, and you absolutely have to account for it.
So let's boil it all down. What did we learn? 3 core ideas. Pods, they're your temporary workers doing the actual job. Services, they're the reliable managers that give you one stable address to talk to. And ingress, that's the intelligent front door that lets the whole world in.
Look, understanding this flow, from ingress to service to pod, it's not just theory. It is the absolute foundation for building truly robust, truly scalable systems in the cloud. So now that you know the rules of the game, the only question left is, what are you going to build with it? Thanks for joining me.